Hi, these are 2 notes, distance formula. Objective, you'll be able to find the distance between 2 points. Similar to what you see like on iPhones and the maps on your phones, the distance between 2 points to figure out how long it might take you. For the distance, I should say. So you can find out how long it will take you. So what is distance? Well, you guys already have somewhat of an idea, but distance is going from point A to point B and tracking how long that distance is between A and B. The length. So distance between 2 points. The distance between 2 points is the length of the segment with those points as its endpoints. So start to finish. The distance between 2 points is the absolute value of the distance between their coordinates. So distance is always positive. That's why we have the absolute value. Mathematical notation to make sure that's always positive. So first thing first, I want to recap. What is the absolute value of 6? Well, you know that's just 6. The absolute value of -9 is just 9. Absolute value of -12 is 12. The absolute value of -596 is 596. Some symbols of what it will look like here. The length of PQ, if P is x1 and Q is x2. To find out that distance, what we do, PQ is equal to x1 minus x2 and the absolute value of it. Or we could do x2 minus x1 and the absolute value. So the distance from the start point to the finish is the same thing as the finish to the start. It's the same distance. Hence why we have the absolute value. And that's why x1 and x2 are interchangeable. So example number 1. Let's just first count out the distance as if we were like in kindergarten. So how far away is B from E? So that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 steps to go from B to E. So the distance is 10. Now that's old school. The way we could do it real quickly, we could first subtract the two values. So -6 minus 4 gets us -10. And the absolute value of -10 is 10. So both ways gets you a length of 10. That's good to count boxes when it's easy to count. Make life easy. This one, let's go old school again. We're going to count the distance by counting the boxes. So 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. So it's going to be a distance of 13 if we count the boxes. If we do it the algebraic way, we do -6 minus 7 gets us -13, and -13, the absolute value of that is 13. How about the distance here from -9 to 2? Well, -9 minus 2 is -11. The absolute value of -11 is 11, so the distance is 11. So it's a good idea sometimes just to use the subtraction when they're farther apart. It's easy to count boxes when they're close together, but when points are farther apart, it's easier to find the coordinate and then do the subtraction on the absolute value. So now let's throw the same concept just onto a graph. So first we find the coordinates. B is 3 to the right, 4 up, so the coordinate is 3, 4. E is 7 to the right, 4 up, that's why that coordinate's 7, 4. What we got to do when it's a horizontal line, we subtract the x values and find the absolute value of it. So 3 minus 7 is -4. The absolute value of -4 is 4, so the distance between B and E is 4. Now when it's small, yeah, we could have just counted it 1, 2, 3, 4. But when they're bigger, it's easier to do it this way. So let's get comfortable identifying the coordinates, subtracting, and taking the absolute value. So once again, B and E. So B is the coordinate 3, -3. E is the coordinate 9, -3. So 9 minus 3 gets you 6, and the absolute value of 6 is 6. So the distance between B and E is 6. And when it's vertical, we still do the same thing. We find the B and the E, those two coordinates, so 5, 7, 5, -3. Then we have to subtract the Y values, so 7 and -3. So 7 minus a -3 is 10. The absolute value of 10 is 10. So the distance between B and E is 10. Now how can we find the distance if the line is on a diagonal? Well, when it's a diagonal, that's when we could use the distance formula. We got a distance formula for it to do diagonal lines. So what is that distance formula? Well, distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. The distance formula is derived from the Pythagorean theorem, which we're going to talk about a little bit more later on in the course, but they are related to one another, the distance formula and the Pythagorean theorem. So, how are you going to find out the numbers for x1, y1, x2, y2? Well, that you just find the coordinates. So you know the coordinates of B is 2, 8, and E is 9, 3. B is the first coordinate, E is the second coordinate. And using that information, I'm going to slide this up a little bit. And I'll show you the work. So now that we got the coordinates, we just do the same thing that we did before. We substitute them in. My x2 value is 9, so I put in 9, minus my x1 value, which is 2, so 9 minus 2, squared, plus y2, which is 3, 3 minus my y1, which is 8, so 3 minus 8, and square that. 9 minus 2 squared is 7. 3 minus 8 is -5. 7 squared is 49. -5 squared is 25. 49 plus 25 is 74. So it's the radical 74. Now, we could simplify radicals, just in case if you forgot how to do that. How do we do that? Well, square root of 54. What we do, we do square root of 54, we break down that 54 and we divide it by a prime number. So 54 divided by 2 is 27, so we have 2 and 27. 27 broken down by a prime number, so 27 divided by 3. We get 3 and 9. 9 is also divisible by a prime number, so we get 3 and 3. We cross out the composite numbers. We circle our primes. Now square root, that means you need 2 of the same kind in order to bring it on the outside. So this 3 matches up with this 3, so you put a 3 on the outside of the radical. And now 2 and 3, they don't match, and they don't have any of the partners, so you still got to put it on the inside, so 2 times 3. When you have multiple numbers on the inside of the radical, you multiply them together. When you have multiple numbers on the outside of the radical, you multiply those together. So in this case, the answer is going to be 3 radical. 2 times 3 is 6, so it'd be 3 radical 6. Now square root of 28, what that looks like is what you see here. Square root of 28, breaking down to 2 times 14. 14 can be broken down to 7 and 2. We eliminate the composite numbers. We circle our prime numbers. This 2 matches up with this 2, so it's a 2 on the outside, and that's 7 goes on the inside. It doesn't have any partners to go on the outside. Why don't you try square root of 36? So square root of 36 is 6 times 6, and it's both 6 and 6. When you have a match, you could actually just take it right on the outside already. So the answer to that is 6. Now square root of 21, that's a tricky one. We have 3 and 7. Since both 3 and 7 are prime numbers and you don't have any matches, you just leave it as square root of 21. So sometimes those radicals won't break down any further, and they're already broken down as far as they go. For right now, we're focusing on distance, so we're not going to worry so much about breaking it down. So, looking at this problem, once again, we're going to find the distance between B and E. We're going to use the distance formula. So first things first is to identify the coordinates B is 2 to the right, 5 up, and E is 9 to the right, 2 up. Now 2 is my x1, 5 is my y1, 9 is my x2, and 2 is my y2. That's the order. We're going to plug these numbers into that equation. So that being said, let's slide that away. Let's plug in our work here. So x2 is 9, so I put a 9 in the x2 spot, minus my x1, which is 2, squared, plus, and then my y2, which is 2, so I put a 2 in, minus my y1, which is 5. Plug them in, and I simplify. 9 minus 2 is 7, so we do 7 squared. 2 minus 5 is negative 3. So we're going to be doing negative 3 squared. 7 squared is 49, and negative 3 squared is positive 9. 49 plus 9 gets you 58, so our answer is square root of 58. That's the distance between B and E of what we have here. That's the distance. Alright, looking at this one. The coordinates of B is 3 to the right, 3 up, so the coordinate is 3, 3. And then my E is 9 to the right, 9 up. So if we label it, x1, y1, x2, y2. Now we got to plug them into the formula. x2 is 9 from there, minus x1, which is 3. And then y2 is 9 minus y1 of 3. So 9 minus 3 gets you 6 squared. And this one's also 9 minus 3, which also gets you 6 squared. 6 squared is 36. 36 plus 36 gets you 72. So the answer, the distance between B and E, is square root of 72. B and E, we identify the coordinates. Then we write above our x1, y1. So first coordinate gets the 1s, so x1, y1. The second coordinate gets the 2s, so x2, y2. Now to find that distance between B and E, we're going to plug it in to the equation. My x2 is negative 6 minus my x1, which is 7. y2, which is 6, minus my y1, which is 2. Negative 6 minus 7 gets you negative 13. 6 minus 2 gets you 4. Negative 13 squared is 169, and 4 squared is 16. 169 plus 16 gets you 185, so we have radical 185 is the distance between B and E. Alright, ladies and gents, this is your classwork. 2-2 CW1 distance formula Google form. And the homework is 2-2 HW1 distance formula Google form. If you have any questions, feel free to email me or come to Extra Help. I'll be happy to help you out. Alright, have yourself a nice day. Bye-bye.